Go. Okay. Ahmed, come on, we're starting. Now, last class we were talking about averages, but there are many different types of statistics you can use to describe your data, and average is just one of them. Not only that, we actually talked about different types of average. So we have the mean, the median, and the mode. So it's not just simply an average. But average by itself is not enough of a summary of the data. So as a simple example, suppose you have these three numbers, -1, 0, and 1. And if you calculate the mean, you get 0 there. That's fine, isn't it? And suppose I have these three numbers, let's say -10, 0, and 10. And if you calculate the mean, what do you get here? You get 0. So if I just said you have two groups of data and they each have an average of 0, that's not really enough of a summary, because you can appreciate that these two sets of data are quite different. So what's missing now from our statistics is some way to measure how spread out the data is in the space. So we kind of have it in our mind that this data is more clustered together than this data is. And we need a way to measure what we call the spread of the data. So let's see how we can do that. We can do that using a statistic called standard deviation, which is represented by the Greek letter sigma here. Now, I'll give you the formula for what it is, and then we'll explain exactly what it means. Okay, so can I scroll down? Yeah? Yes? So let's just call our data x1, x2, etc. up until xn. With the mean, we'll write as x bar like that. Usual symbol for mean. We define the standard deviation as the square root. And what you do is you add up the difference between the data and the mean squared, and you divide by n here. So I'll give you an example with some simple numbers. Suppose, for example, you have the three numbers, we'll say -1, 0, and 1. Okay. What's the mean here? The mean is 0. So the standard deviation is the square root all over 3, because you have three numbers here. And what you do is you take each data point and compare it to the mean. So it's -1 minus 0 squared plus 0 minus 0 squared plus, and then the last one, 1 minus 0 squared. So if you put that in on the calculator, you would get root 2 over 3. And your calculator might even simplify that for you.
So the square root is only for the one above, yeah?
The whole fraction.
The whole fraction.
Yeah. That's why I have it as root 2 over 3.
Root 6 over 3.
Root 6 over 3. What's that as a decimal?
0.81.
0.81.
0.6.
Okie dokie.
What's x stand for?
Say again?
What's x I stand for?
Oh, just like the data, like x1, x2, x3. Now, I'll use Excel now to try and explain what the meaning of this number is. So if we say, oh, we have some data and its standard deviation is 0.86, what exactly are we saying? So when we say the average is 0, in our mind we kind of picture, oh, if we think about our data, then the middle of it is somewhere near 0. You know, if I said the average height in this room is 1.6 meters, then we kind of imagine all the heights are somewhere near this. Yeah? So let's see what we mean when we say standard deviation. I'll just, when you're ready, I can switch to Excel. Do you have that? Yeah. Okay. Is that a yes or a no? That's, I can continue? Okay. didn't lose anyone from this morning. I only gained. I gained 1, 2. Who else did I gain from this morning? You were here this morning, weren't you, Andrew? Yeah, how could I forget? Oh, yes, I gained someone else, didn't I?
I was on the phone.
Yeah. Okay, can I switch now to Excel? Yeah, okay. So let's, I'll try and demonstrate with an example with a bit more than just 3 numbers. So let's just say I have 10 numbers. So we'll just make up data here. Data. It's not showing up even though I switched it. Let me pick duplicate here. Computer. Yeah, you can see now. Right, so I'll just make up some numbers. We'll just say, I don't know, 6, 7, 6, 8, 8, 2, 9, 5, 6.
This is not in the video, yeah?
7. No, it's not. No. Well, it's on. I just want to give you a feeling for what we mean when we say standard deviation. Okay, I'll use Excel to calculate a couple of things. So, how do I get the mean here? Well, that is the sum of all these numbers, isn't it? First, hang on. Equals sum, bracket, all these numbers, and how many is that? 10. So the mean is 6.4. Okay. Now I want to get the standard deviation. I think Excel actually has this function built in, so so I don't have to type square root and all of that's a bit messy. So I think it's built in as, I think it's this one here.
Yeah.
And here the standard deviation is 1.85, roughly, if you were to calculate it. Now, I'll try and explain what that means here. So, difference. How far away is 6 from the mean? 0.4. Yeah, so in other words, the distance between 6 and the mean is 0.4. And how far away is 7 from the mean? Is it? So not 0.6?
Yeah. 0.6.
Yes?
Oh, yeah, 0.6.
Yeah. How far away is 6 from the mean?
0.4.
0.4. And so on. Okay? Now, suppose I was to average all these differences here. So that would be sum all of these numbers divided by 10. What would that number represent?
Standard deviation.
No, but what would be the meaning of this number? The average of the difference. So in other words, this number here of 1.4 represents on average how far away each point is from the center. So it's kind of like, it's almost like a radius. It's how far away the data is from the average. Some numbers are closer than 1.4, yeah? Some numbers are further away than 1.4. But most numbers are about 1.4 away from the average. Either too big or too small. Now you notice that that's not exactly the same as standard deviation. But the two will always be quite close. And in fact, the bigger your data, the closer that difference will be. So if I had 100 numbers, then what I would get here and what I get here would be even closer. But the point is, you interpret this number as being kind of like this number, that the standard deviation tells you how far away your data is from the average. It's not exactly that, because here it's 1.85 and it's really 1.4, but it's just our rough interpretation. So if I say the standard deviation here, if I go back, if I say the standard deviation is 0.816, then what I'm saying is most data is about 0.816 away. And that seems about right. For example, how far away is -1 from the average? 1. And 0?
0.
And 1?
1.
So yeah, the average of those three numbers is 0.67. Close to 0.8. It's not too bad for only having three numbers. So the standard deviation, its meaning is it's a measure of, roughly a measure of how far away each point is from the average. Yeah.
Why don't we use variance?
Variance.
Yeah.
Variance is, we'll actually get to that later. Variance is the standard deviation squared. Now, the reason we don't use that is because the units would be wrong. For example, imagine these x's were measuring meters. Well, not meters because that's -1, but anyways, some unit here. Then the unit for this would be the same unit. So if you were using meters here, it would be meters here. But if what you were saying, the thing called the variance, the unit for that is meters squared. So it's not the right unit. But it does have a similar meaning. It's a measure of how spread out it is. So we'll calculate some more now. But before we do that, there is another formula for calculating standard deviation which you might find easier to use and quicker in the exam. And it actually works out to be the same answer, exactly the same. I'll just scroll down a bit. Do you have this? Yeah. So just before I show you the formula, this symbol here means mean. But another way to write it is like this, which is a little bit more convenient for my next definition. So another formula for standard deviation, which by the way will give me the same answer, is let me think, this minus this, and let me just think, I put in here x squared and here x squared like that.
This is the second formula.
This is the second formula for standard deviation. It will give you the same answer. And to prove that, I'll use the same data for this one here.
I don't understand though. If you minus both means, like, what's the difference between x squared there?
It's I'll explain now. It nearly looks the same, doesn't it?
Yeah.
So the difference is quite small, but it's important. Here, this means you square the data and get the mean. Here, this means get the mean and then square it. So let me show you an example. So let's say I have the data -1, 0, 1. And let's first calculate this. What does this equal? The average. Well, 0. And if I square it, still 0. Okay, fine. Now, that's that done. Let's calculate this. So I need to calculate the squares of the x's. So what's -1 squared? Let's try again. 1. 0. And the next one? 1. And if I get the average of these three numbers, what do I get?
0.
No? 2 over 3. 2 over 3. Right, Amjad? Yeah, okay. So, I said standard deviation squared should equal 2 over 3 minus 0. But I want standard deviation, so I should take a square root, and I end up getting the exact same answer. Yeah? So this is much more convenient formula to use. And this is kind of what they expect students would use in the exam. It's much quicker to run through this than the other one.
So can we use a bigger number? Like, not 0?
Okay, we'll do another example. Yeah.
Don't you divide that formula by the frequency?
No frequency, yeah. We haven't talked about frequency. Okay.
Steven, where did
Yeah.
you get that 0 from? From the x,
Which 0?
from the mean squared?
Oh, sorry. This 0.
Yeah,
That's this guy, which is
mean squared.
mean squared, yeah. So that's my formula.
Square the mean minus mean.
And this is our data. Yeah, that's it. And then this is the answer here.
Can you do another example of this?
That's what Mo asked.
Or deviation? Good job, man.
Yeah. Mo examples, no problems. Yeah. Right, continue. Yeah? Yeah. Okay. So, scrolling down. Right, so this is 3 numbers isn't quite enough for an exam. So we'll say something like 1, 3, 5, 2, 1. This is our data. Alright, so step 1, let's get the mean. So that's 1 plus 3 plus 5 plus 2 plus 1 over 5, isn't it?
Yep.
5, 6, 7, 8, 9, 10, 11, 12. 12 over 5 is the mean. Yeah. Which is, what's that, 2.4? Yeah. Now, we often want the mean squared, so that would be 144 over 25 then. Whatever that is.
5.76.
5.76, okay. So we're halfway done. Next we need to get the x squared data. So what would those numbers be?
1, 9, 25, 4.
1. And now we need to average them. 1 plus 9 plus 25 plus 4 plus 1 over 5. So what's that? 35, 4, 8 is it?
Yeah,
I think.
40 divided
8 in total. So, standard deviation squared equals 8 minus 5.76, which is 2.24. So, yeah, square root of this number is the answer. So what is that? 1.5?
Yeah, 1.49.
Okay, it's not bad for someone without a calculator. So, that seems about right. If you look at these 5 numbers, the average is 2.4, and they go from 1 to 5. So you're saying each one is about 1.5 away from the centre. So you can even picture this on a number line. Here's our data on a number line. We have a number at 1, and then we have another one at 1. Then we have one at 2, 3, nothing at 4, and then one at 5. And the average is here at 2.4. So some of the data is, what's that, about 1.4 units away. Some of the data is more away. So yeah, on average it's 1.5 away from the centre, roughly.
Actually,
Yeah?
it is 1.5 because it's 1.496.
Well, boom.
Stephen wins.
Alright. Let's have a look at an example with frequency unit. Mm-hmm.
I think this is why it's useful to always get the frequency and stuff. I'm not
Got that? Yeah?
Sir, but why do you do this? It's not accurate. It's like one number can skew the average by law. Like, if, like for example, if they're all within 0.4 and then all of a sudden one is like within 5. Then that's
Let's
not
actually
right.
switch back to Excel and see that as an example. So, you mean like take one of your data numbers here and make it really big?
Yeah.
Let's see what happens. So let's just delete that here. Can you all see that okay?
Yeah.
Right. So what would happen if I... Oh, you know what? And let me put them in order as well. So, data, sort... Where's sort? Yeah. No, that didn't work. There we go. So what's the median actually? 1, 2, 3, 4... the median is 6.5. Which actually is pretty close to the mean as well. Now, look what happens if I make one of the numbers really large, like the last number, 9, make it 900. I haven't really changed the data much, except for 1 point. But you can see here, this has radically changed the mean and the standard deviation, although the median is not affected much. Now, it means that, you know, you have it's not appropriate to use mean and standard deviation when your data has something like this in it. Do you remember the name of this type of point?
Skew?
No, outlier, yeah, yeah. It's skewing the result, yeah. Now, there is actually something that's like standard deviation that you can use to calculate a spread that isn't affected by outliers. And that's actually what you were saying earlier, the interquartile range. That's not affected by outliers. But you're right, Mo, if it's not appropriate to use this if you have data that's like this. But I mean the data that you collect in lab. I mean, if you're doing an experiment, which is more likely? You did something wrong, or it really is 900 here, you know?
No, you did something wrong.
Yeah. So in scientific context, you don't usually get this, but in a business context, you might, you know? Okay, let's have a look at an example with frequency in it. So let's say you have, we'll keep it small. We'll just say x could be 1, 2, or 3. And we'll say we'll have 6 of these, 7 of those, and 2 of those. And we want to calculate the standard deviation. So first things first, we need to calculate the mean. So what would that be here? How would I get that? 6 times 1, which is 6, plus 14 plus 6, all over 15. No. 15? Yeah. So 26 over 15. Wait, and we want to square it, so I might as well do it at the same time. So if I square that, what will I get? What's it? 3.004. For basically 3. Yeah. Okay. What do I calculate next? Next I calculate this one. So the only thing I need to do to calculate this is I go back to this table, and instead of having 1, I need to have 1 squared, which is 1. And 2 squared? 4. And 3 squared? 9. And I repeat the process. So this is 6 plus 28 plus 18 over 15. So what's that, please? 3.46 in total, yeah? So standard deviation squared is 3.46 minus 3.004, which is roughly 0.46 if you round it off. But don't forget, we want to take the square root. So if you square root that, so what's that, about 0.26 or something? Oh, sorry, it gets bigger, not smaller. 0.678, roughly. There's not much difference here. You can see how convenient having this method is compared to the first formula, right? It's a lot easier to be working with.
So for exam purposes, we don't approximate, right? So because...
Oh, yeah, I'm just being lazy. But in the exam, yeah, you're going to have these numbers on your calculator, so you can use the full thing. Now, in the exam, they want to see your work, but I believe you can use a mode on your calculator to calculate standard deviation, even for these types of problems with frequency tables. So let's see if we can figure that out.
Oh, yeah.
Yep, it's on it, isn't it?
I think.
Okay, once you write that down, we'll have a look at that with the calculator. Yeah? Yeah. your graphing calculator, dude?
Yeah, but I don't know how to do it. I'll Google it here.
Right. So I'll just do a simple example first. Can I scroll down? Or scroll to the side here? I'll just go back to the example of minus 101. What do? We have to put our calculator in statistics mode first, I think. So that's mode statistics, which is 3. And I don't think it matters too much, but I think number 2 is the best one, because number 2 means linear, but I'm not even sure if you have to pick this. Let me just see what happens. No, you don't even have to pick anything there. So I have it in statistics mode. Can you see? Yeah.
I'm gonna show it to you after. Yeah. I think you cleared.
Mode. Oh, hang on. Well, I just picked shift mode. Oh, sorry. Mode statistics,
Yeah, and press it.
and I cleared it.
Yeah.
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 So you do that. Mode
Oh.
statistics.
No.
Oh well, I actually I do want the table, so I won't clear it. So I just pick 2 here. No, that's no good. That's actually not quite the
Maybe pick one for variant.
1. Yeah. So if you want to press this mode 31. Mode 31. Do you have this on your screen?
Yeah.
Right, so minus 1 equals 0 equals 1 equals. So I just typed in the 3 numbers. Yeah? Now, to clear this away, don't worry, if you press AC, which you should, it doesn't delete the data, it just clears the screen. But it's still stored on the calculator. AC just. Now, if I press, if you look here, Shift, and you see this button here, Statistics, number 1. Let's see. Now, don't pick anything yet, because I can't remember which one it is. Maybe it's in number 2. No. Oh, that's if I want to change the data. Shift, Statistics, 1. Hold on. I'll get it now. Shift, Statistics.
4.
Oh, for flip's sake. Shift, Stat. He says distribution. No, it's not.
It's 4. It's 4.
Is it 4? Yes, it is 4. Thank you. So shift, statistics, and it's, I don't know what the variables. 4. So which one do we want? This is how many data we have. We know what that is. So let me show you. What should we get if we pick 1? We should get 3, which we do. Shift, statistics, 4. What do I get for the average here?
0.
0, and I do. Shift statistics for standard deviation is 3. And what do you remember what we got here? It was like 0.681, was it? There you go. Now let's do an example where we have a table like this one. So here, you watching guys? It's mode statistics, which is 3, and then 2. 2. You can think of it as two rows. Oh no, sorry, I lie. I tell you lies. House of lies. Mode statistics. I thought I picked 1 last time. No, it's not 1. Yeah, but I want one that has the frequency table in it. That's what I first had.
8. Maybe.
You have to turn it on, isn't it? Shift mode. Oh, it's hidden. Goodness. Oh, frequency on. Alright, thanks for that. Shift mode. You have to scroll down to stats here, was it? And then turn frequency on. Now, yeah, it's not that easy to use, is it? And then you can go to, yeah, mode statistics. And is it pick 1? Now it's 2. Well, I think 1 would have worked as well. Mode. Ah, but that's okay. That's okay. No, 1 is better. 1 is better because then it just has x and frequency in it. Right, so let's put in the x's. So our x's were 1, 2, 3. And the frequency, 6, 7, 2. And let's clear this. Shift, statistics, variance, and standard deviation. So hopefully I get 0.678 or something close to this. Yeah.
You can't find the statistics, one.
What the heck is that calculator? I don't know how to use that one. It's a new one, yeah. But why didn't you buy the one I recommended?
This, yeah.
It's not in this.
It
Oh,
is.
it should be.
Is that the Casio? Show me. Give me.
It has to be on it.
I don't know. This one's a different one.
It is on it.
Yeah, but the frequency. Try to do the frequency.
Oh, I see. Okay, mode. I understand what you mean now. Statistics. But it's already turned on.
Is it?
Yeah. It's on by default.
This thing is weird.
Yeah. Anyways, it doesn't matter because in the exam you have to show your work anyways.
Yeah.
I'm just showing you that you
Check your answer.
it's for checking your answer only. Yeah. There is another way to check your answer, okay? So look, if you don't have a fancy calculator, let me go back to Excel and put this back to 9. Listen. I'm waiting, listen. So, if you don't have a fancy calculator or you're not sure how to check your answer, there is a rough way to check your answer as a rough rule. So, when you calculate your mean and your standard deviation, if you calculate the mean plus twice the standard deviation and the mean minus twice the standard deviation, let's see what we get. That's equal to the mean plus twice the standard deviation. And here this is equal to the mean minus twice the standard deviation. Those two numbers there should roughly equal the start and the end of your data. Roughly. Now actually in this case it's not so bad. Our biggest number is a 9 and this here says it should be about a 10. And our smallest number is a 2 and this one here says it's about a 2.7 or a 3. So this is a way to know if you got an answer that's at least roughly right. You know, so if I got an answer like standard deviation is 5, then if I checked roughly here, I would feel like I've done something wrong. Now, what is likely the student's mistake here if they got a standard deviation of 5? What do they likely do wrong? Like, what do you think is the most likely mistake that the student could have made that would have made the standard deviation too big?
They input the data wrong in the calculator.
They did what? No, that's it, yeah. They forgot the square root. So, here maybe the student forgot the square root of the 5, and you can see that the answer is wrong, because the biggest number should be 6 plus 10, which is 16. That's too big. And the smallest number should be 6 minus 10, which is minus 4, roughly. That's too small. Okay? It's good to know these little things for the exam, so that you can know that if you got your answer at least roughly right. So this would have been a signal to you in the exam that you forgot something, and in here it's too big, so you must have forgot the square root. Yeah, just a little, you know, these little tricks will be useful when you're doing an exam to make sure you are on the right track. You got it on that one? Good.
This is our example.
Gives you
Nice.
Instantly.
Nice. Okay, so for the last few minutes, I just want you to get started on these. In the exam, the most common type of standard deviation question that they ask is calculating it from a frequency table. In fact, what they usually do is make it a group frequency table, but that's no big deal. So, yeah, just use the midpoint then. So like if the first one was say 0 to 2, then you would just use 1. Something like that. So that's the most common type of exam question, is calculate the standard deviation from this grouped frequency table. So that would be like question 7 as an example. That would be a very, very common exam question. Like, I think 80% of exams have this question. Okay. So anyways, I'll let you try these for a few minutes now. If you just want to practice these, please. I'll close this here.